Um, uh, let me ping everyone, or not everyone. Let me ping the role in my server, and then we can get started. Let me just see if okay, good. Audio's working. Okay. We are learning Jecs today. I have literally never used Jecs. Give me 1 second. Let me do something. Okay. I have not used Jecs. I have not used any form of Roblox ECS. So today, whoops, this is going to be interesting. I guess let me start by, let me put my OBS on that screen. Let me start by looking at, there's not really documentation. However, there are examples. So how about, let me look at, there's a how-to folder. Guess let's take a look at this then. I'm just gonna copy this so I can test this out. Guess this would be a server script, right? Let me do that. It would be replicated storage dot packages dot jecs. Okay. Let's see. All right, so we have our world. A world stores entities in their components and manages them. Okay. That makes sense. Okay, so we're actually making a component. Okay, that returns a component ID, or yeah. It returns a component ID, and then we make an entity, and then we are setting the entity's position, which uses that component ID to, what is vector.create? I've never seen that. Is that just, that's interesting. Yeah, that is interesting. Okay. Solver will enforce that type. All right, cool. So I guess, yeah, let's just test that out. 1, 2, 3. Boom. Works how I thought it would. Let's check out the second thing, I guess. Oh, I'm tired. That doesn't, yeah, that doesn't work. I would have to do that. Okay, so we're making an entity and we're printing it. What does this return? Is this, this uses object? No, it's not object oriented. Okay. Except it looks like the world is, okay. Damn. I'm yawning. this would create an entity with an ID. Okay. So I guess... But then what would happen if I made two entities with the same ID? Or would they be the same, I guess? Format of the entity record. It's a little bit confusing. So let me just run the game and see what that prints. Dense equals, wait. Oh boy. Okay. I don't understand that. Entity ID will have a corresponding... Oh my gosh. Okay. Keeps indices into arrays of data. The format is usually row number, but... Wait. Oh. That's just the ID, is it? Wait. Because it's printing that ID here. That's 272. How's the ID the same every time? If I make... Huh. So why is it starting so high? That's interesting. And then... Yeah, 42. Okay, I guess that kind of makes sense. Okay, this is a lot. Okay, I don't think I necessarily have to use that. ECS generation. So I guess that just generates an ID, like manually without creating an entity. 272 and 0. Index and generation. No. So that gets, I guess this gets the ID of that. And then generation. Man, that's kind of confusing. Okay. And then delete the entity. Notable, okay. Recycled entity. Okay, that's... Man, that's confusing. Okay. Very confusing. But hopefully I'll understand it more in a little bit. Let's try out the next example. We have 003 components. Let me copy that. And then I will paste this here. Okay, so we're creating a component into something that is added to an entity. Components can simplify, tag, can simply tag an entity. This entity is an NPC. Attach data and create relationships. Blah blah. Okay. Okay, so we got a position in a help entity. Or components. Components are keys to ECS storage columns. Rows are entities. Columns are components. Cells are the component data. Okay. That makes sense. Creating a key that I will use to index into the storage. Component ID tells. Okay. Let's see what those IDs are. So we have 1 and 2. So I guess that just starts from 0. And then we're creating an entity. Can this be any type? Like, would I be able to do complex types? I guess I would, because it's just a generic. So we're setting... Set works for both adding and updating. Okay. So we're giving this entity the position, and then also health, and then we are updating it. So we're adding those components. That's how you read data. Okay, so this is how we would get the position in the health entity or components from that. Okay. That's easy. POS assert. Okay. Yeah, we could just assert that. That's good. And then removes a component from an entity. This removes the data from the storage column. The entity will no longer have that component. If the entity doesn't have the component, remove does nothing. It's... Man, that's a big word. Idempotent, I guess. This makes it safe to call remove multiple times. Remove only removes the component. It doesn't delete the entity. Use world delete if you want to delete the entire entity. Okay. So I can remove health entity, and then this will be nil. And then the position is still the same because we didn't remove it. And then we can remove it again, and it won't do anything. Components are keys, storage columns. Components are column keys. So okay. Guess that makes sense. Let's take a look at tags now. Using Jecs.tag to pre-register a tag entity, which will be allocated when you create the world. Or let's look at this first. Zero bytes of storage per entity. Okay. Okay. I don't quite understand the component range thing, but I'll figure that out eventually. Okay, dead equals Jecs.tag. And then we're making our world, creating the world after the components. Okay, that's important to remember, I would guess. Tags are added using world :add entity component. You cannot use world set. That makes sense. So okay. Makes sense. That's easy. Okay, tags are easy. Entity singletons. You can do that? Okay, that's cool. Oh, I would have to Windows V. Singletons are components for which only a single instance exists on the world. They can be accessed on the world directly and do not require providing an entity. Singletons are... Ooh. Wait, that's really cool. Wait. So I can just set... Okay. Let me space this out better. I don't like how that's spaced out. So when I'm creating this component, I can give it data as if it were an entity, and I can use this like it were a global thing. That's nice. Or network socket. Okay. Okay, that's interesting. I like that. Let's check out the next one. Boom. And okay. Okay. So yeah, components are entities technically, I guess. If a game has a component position and velocity, there will be two entities for each component. Component entities can be distinguished from regular entities as they have a component trait. It may seem odd. Why make components entities? The answer is uniformity. All APIs that work on entities also work on components. You can set metadata on components. You can query for components. You can create relationship between components. Ooh. That's interesting. That's very interesting. So, Jecs.name. So that's just like... Huh. Oh, this is probably why it starts at like 270. That's probably why the components start at like 270. Okay. So, we're giving our position component a component called name, which I guess is just like a default thing. What else is there? There's a lot. Takes an ID of string. So yeah, that is just a, okay. And then world : get. So we're printing the name of position, and the name is a component itself. World : has position. We're checking if the position... Oh, I get it. It checks to see if it has the component, which is this component. Okay. That seems very confusing at first, but I think I understand. So, actual components will have a component called Jecs.component. Okay, you can only have 256 I guess that means you can only have 256 components, right? To increment the high component ID or create your own entities and then add Jecs component trait. High comp ID, world entity, world add. I don't know what this does. Let's play, I guess. Oh yeah, that doesn't print anything. Okay, that does make a lot of sense. Let's check out this one. So this would be if I register it before the world. Position gets registered here. However, if you try to set metadata, you will find this doesn't work without the world instance. Instead, Jecs offers a meta member function that can forward declare its metadata. Okay. It's interesting. I'm not quite sure I fully understand. Check out pairs. Here's the next thing. Grab. Where is it? Here it is. Pair. Okay. This one might be confusing, but we'll see. Pair is an ID that encodes two elements. Okay. I guess I'll just take a look at the example and I might figure it out. Okay. Likes Alice pair. Likes is an entity. So this is, I guess, associating the likes and Alice entities together. And then, okay, entity equals world entity. Pairs can be used just like component IDs. World colon has entity pair likes Alice. World set entity pair owns comma car. You know what? I think that makes sense. So if I had owns comma truck, I could add it to this entity and then put a purchase date. I believe that's how that works. And then truck itself can have its own components on it to store data. Ownership data equals world colon get pair owns car. Okay, I think I understand this. Check if an ID is a pair using Jecs.isPair. Okay. Okay, I think I understand this. I don't know how much I would have to use it, but I think it makes sense. Let's check out queries. Whoops, wrong thing. Okay, let me put that, and then queries enable games to quickly find entities that satisfy. Okay. This makes sense. So we're making a position and velocity component. In world colon query. Okay. So it's finding to see if it has both, not either or. All right. So it's checking to see if entity position. So this is returning the entity and then the position component and then the velocity component of each. Or not the components itself, it's returning the value of the component. Oh, hey, Edward. So I don't know if you are familiar with, I don't know if you're here for Roblox scripting, but essentially Jecs is a library which allows you to use an entity component system in Roblox. So instead of having like scripts in everything, I don't fully comprehend it yet, but basically you have entities and then these entities can have components. So you could have like a gun entity, and then you can have, or no, let's say like a truck entity, and then you could give it a component for price, and then you can give it a component for like the health that it has, I guess. And then you were able to query to see if that truck has certain things. It's kind of complicated, but I'm trying to learn it so that I can make a video tutorial on it in the future. It is very confusing at first. I'm very confused so far, but I'm somewhat understanding it. Okay. So if I add position to this entity, and then I add position and velocity to this one, what does this say? Do you not have the built-in component? Okay, that's confusing. The component. Okay. So only entities E2 and E3 match the query position velocity, because they both have position and velocity. So let's play and see what that does. Okay, so that's printing the ID. Cool. Oh, thank you. I'm glad that they helped. Fusion's awesome. I didn't really understand it until I started watching YouTube videos on it, like a few years ago. Actually, I don't know when I started learning Fusion. It was probably a year ago, I would guess. It was 0.2 or 0.1, I can't remember. Okay. So we're making a walking component. Position, velocity, and walking. This one doesn't... Okay, wait, what is this one? Query operators. Filters are extensions to queries which allow you to select entities from a more complex pattern, but you don't actually compare about the values. So this is like a tag, I guess. So we're checking to filter entities that have position and velocity but we don't need the values. Just want to know they exist. So I'm guessing what this means is it can have the position and velocity component. No, position or velocity? Okay, no, I understand this. So this by itself makes it position and velocity. But this makes it so it also has to have walking. But I think velocity is optional because it says without there. That's confusing. I don't quite understand that. Okay. Well, I guess we'll go on to the next one. I haven't quite understood how I would actually implement this into a game yet. I guess this would be... You know what? I want to try making a tycoon with this. Tycoon would be great with this, actually. Because I could have different components for each upgrade. Or, yeah, for each upgrade, and then... I think that would be a good idea. Okay, let me move on to the next one, though. That's a lot of text. Let me get my require. Okay. Understanding the basic architecture of queries helps to make the right trade-offs when using queries in games. The biggest impact on query performance is whether a query is cached or not. Is an archetype ECS. Entities with exactly the same components are grouped together in an archetype. Archetypes are created on the fly. Okay, that's nice. So I guess it's sort of hashing the data so that if two entities are the exact same, they will it'll be easier to reference it, I guess. So we have position, velocity, mass, and then we are adding the position to this entity and then adding velocity to this entity. And then, okay, we're adding position, velocity, and mass. So it's archetype position velocity already exists. So it's getting that because we already made it over here. Then we're adding mass. I'm not entirely sure how that works, but I guess, yeah, that's a query thing. So let me take a look at this. Okay, wait, are archetypes... I can't tell if archetypes include the data or if it's just if it has that component, ignoring the data. I'm not entirely sure about that. Main thing is to remember that a cached query does not have to search for entities. Iterating a cached query just means iterating a list of pre-matched results, and this is really, really fast. Uncached query. You would have to do colon cached. So I'm guessing okay, so it looks like a cached query would be like if I were to oh my gosh. A cached query would be if I were to like iterate it over a loop many times. So if I had like if I put this in run service stepped or something, then I would want to define it outside of run service stepped and then put it in there. That makes sense. Next up, we got archetypes. I think I'll skip this one because the other one sort of explained it, although I didn't entirely understand, but it's fine. Let me grab this one. This, I think, will explain pairs better. Okay, fragmentation. Actually, no. Maybe, we'll see. Property of an archetype-based ECS implementation where entities are spread out over multiple archetypes as the number's different. Number speed. Okay, let's just see what it does. Alice, Bob, Charlie. So, entity 1 is a pair. So, so entity 1 likes Alice. Each different target creates a new archetype, leading to fragmentation. Okay, that's confusing. Entity relationships. Let's figure this out. Entity graphs. Each and the second element represents the relationship. Target, okay. That makes a lot of sense. Okay. So if I created a pair, let's say I had like a pickaxe. I had an entity for a pickaxe. And then I have like a block category, let's say. Let's pretend this is like Minecraft or Hytale or something. We have a pickaxe, and then we have a pair which is can mine, and then the second one would be like I guess it wouldn't be a list of things, or I don't know. I don't completely understand if you I don't know if you can do like a list of things, but let's say it would be like can mine and then a list of things like stone, iron, diamonds. I think that would make sense. No problem. So Jecs is what's called an entity component system. And entity component systems are very popular in other engines, except Roblox does not rely on an entity component system. So basically you will have it's a little bit confusing. I'm still trying to figure it out for myself. But you have entities, and then those entities can have components which will store data. So let's say you have a character entity, and then on the character you have a position and component and then a velocity component. You can store that data and then query for them. It's a little bit interesting, but I'm still kind of learning. Okay, so let me let me do a little example. So let's say I'm gonna make a multi-line comment down here. You zoom in. We're going grandma mode. So object-oriented programming. Typically you would use inheritance. So let's say you would have like a base vehicle, and then you would have truck, car, blah blah blah, and then maybe you will have a specific types of trucks. I don't know what types of trucks there are. Truck type 1, truck type 2, and then car, let's say you have like I don't even know, Tesla, yeah. So object-oriented programming would be like that. So you're using inheritance to create your different things. So truck type 1 inherits everything from truck inherits from base vehicle. But the issue is, if you, for example, wanted to have some of the functionality of truck inside of car, you're gonna have to reprogram that. But in this case, you could just put it in base vehicle. But let's say we have 3. Let's say we have like helicopter. Let's say you want truck and car to have functionality for stuff on ground, and then helicopter will have functionality for obviously in the sky. You won't be able to easily share that, because then you'll need to make another thing for like ground vehicles right here, and then you would need sky vehicles, for example. It can easily turn into a mess. So that's definitely a bad side about object-oriented programming. But let's say for ECS, you could have let's do like truck type 1, which is a entity, and then truck type 1 will have a it'll have a ground vehicle tag, which a tag is technically a component. And then inside of this we can have like vehicle properties as a component, and then we would do like speed, acceleration, stuff like that. And then if we wanted, for example, our helicopter, we would do sky vehicle, which is our tag, and then vehicle properties would be pretty much the same. But I don't know if that was the best example, but you can easily see how you're not having to branch out as much, and your code won't necessarily be less spaghetti code. Well, I guess it would, but it makes, obviously, object-oriented programming is for making stuff reusable, but ECS kind of takes that to another level. Yeah, it is just composition, actually. So most of the time, I don't know if you've worked with other languages, like Java, but Java doesn't really support composition at all. So you would have to create your own entity component system. But I mean, it's really just personal preference. ECS is very complicated, especially in Roblox, because Luau technically isn't even object oriented. So you're building off of something that's not even entirely supported. So it can get very complicated, but I don't know, it's just really what you prefer. I can see how some people use ECS. I probably won't for most projects, but I'm gonna learn enough so I can make a tutorial on it. I don't know, I like object-oriented a lot, but I thought it could be cool to learn. Yeah, Java's a good language to learn. I find it really fun. A lot of people don't like it, but I like it a lot. It makes everything feel very structured, in my opinion. Let me take a look at what this was. This is a long script. Okay. So, Bob eats apples. Bob likes Alice. Alice likes Bob. Thank you. Then it's checking to see if Bob eats apples. And then this sees if Bob eats anything. Okay, that's really cool. So I'm guessing what I could do with that is you could make like an item component, or you'd have like diamond pickaxe. And then in here, I'm guessing you would do like pear, can mine. I mean, I guess a diamond pickaxe would mine anything, right? And then like wooden pickaxe would have can mine like I don't know, stone, coal, or stone, coal, iron, or just stone and coal. I guess it would work sort of like that. So that makes sense. Oh, no worries. See ya. And then we can query that. Querying for children of a parent. Okay, so this makes... Okay, so this is just... That's really cool. Okay, so this is kind of like built-in... This is just like a built-in tree structure. That's neat. I really like how there's these all of these built-in things, because that makes it... That's pretty cool. And then querying with wildcards and getting targets. So for entity in world. What is target? Wait. Okay, that... Oh, that sees what it eats. Oh, okay. This makes a lot of sense. I actually understand that a lot now. I can see how pairs can be very useful. I've never seen that in an entity component system, though. I don't know if that's like a Jecs only thing, but that's nice. And then wildcard. Dude. Combining relationship queries with regular components. You can combine relationship queries with regular component queries. This allows you to find entities that have both a relationship and regular components. So wait, where's parent? What's parent from? Okay. Parent is just, I think parent's somewhere up here. No? Where does parent get defined? Oh, it is. Okay. So we have position, health, and then the player will have position, health, and then it is a child of the parent. Find all children of the parent that have position and health. So we can query position, health, and pair. Okay. Querying for entities with multiple relationship targets. You can do that? Whoa. You'll get the entity once, but rule target will return the first matching. If you need all targets, you need to use a different approach. Okay. See the targets example for advanced usage. Okay, we'll take a look at that in a little bit. Charlie equals world Charlie. So this query will return Bob once, even though Bob likes both Alice and Charlie. Okay. Querying for all relationships with a specific target. And also query for all entities that have a relationship with a specific target using a wildcard. So it's checking to see if anything has a relationship with Alice. Okay. Relationship pairs, just like regular component, can be associated with data. Oh, man. Dude. Oh, that's awesome. So I could do like, I could have like a diamond pickaxe component. And then that component would have a pair, which would be can mine stone. And then I could add like a mining duration. I could add mining duration to that pair. That's really cool. Dude. And I could make it a child of position, because position is technically a component, because position is, position is technically an entity. Query for entities with each relationship and then get data. Querying relationship with pairs of data. For entity each data in blah blah blah. Entity each data dot amount. Okay. When querying for relationship pairs, it is often useful to be able to find all instances for a given relationship or target. Wildcards may be used for relationship or target part of a pair. Matches all likes relationships. Matches all relationships. Oh my gosh, I can't talk. Using world target is the recommended way. However, if you're in a very hot path and need maximum performance, you can access the relationship column directly. Whoops. Okay. Pairs are cool. I didn't understand them at first, but I get them now. Cleanup traits. When entities that are used as tags, components, relationships, or relationship targets are deleted, cleanup traits ensure that the store does not contain any dangling references, and a cleanup policy provides. It's guarantee, blah, blah, blah. Cleanup actions remove instances of the specified component from all entities. Delete all entities with specific ID. Cleanup conditions on delete. The component tag or relationship is deleted. A target used with the relationship is deleted. Okay. So, world : delete T1. T1 is an entity that we added to that. And then that should print false. When an ID is added to an entity, when an ID added to an entity is deleted, all references to that ID are deleted from storage. Deletes all entities. Wait. Cascading deletion. Dangerous. I have a theory. Could I put a function in here that prints hello? Will that print hello? Attempt to perform arithmetic. So I'm guessing I didn't pass something in. So what does delete take? It takes ECS delete. Am I able to do that? on function and number. I guess not. Actually, yeah, why would that work? Because Jecs.delete is, it's an entity. Yeah, that doesn't make sense. I don't know why I thought that would work. E2 equals world colon entity. World colon add E2 to T2. This will delete E along with T2. Delete target remove. Okay, I think I understand that. Let's take a look at hooks now. Ooh, okay. Wait, so I was right. Sort of? See, it's on add. It's entity ID data. I guess I was right. Yeah, I'm not sure. I guess I was right, though. That is kind of how it works. But what I'm confused about is a function isn't an entity. Oh, never mind. That's just... Okay, no, that makes sense. Transform component ID has been added with data to entity. Health on remove. If delete, entities being deleted, don't try to clean up. Okay. I think that makes sense. Here's the last one. Oh, it's empty. Guess we finished everything. I mean, I guess I should check out replex, right? I might save that for another stream. I might make a stream where I try to make a game using Jecs. But I think I'm gonna end this stream. I think I learned quite a bit about ECS. But hopefully you guys enjoyed. I know we didn't have too many people in here, but yeah, that was fun. See ya.